What's up, everybody? This is Quet, and in today's video, we're going to be going over using higher order functions with more data than we have in our previous videos. We're going to create a class, we're going to create some objects off of that class, and then we're going to use higher order functions to just get some data, manipulate some data with those objects that we have, and we're also going to use the spread operator. So the theme for this video are going to be the characters from Family Guy. More so specifically, three of the families that live on Spooner Street. So we're gonna be all four families rather. We're gonna talk about the Griffins, the Browns, the Swansons, and Quagmire. So let's just get into it. So if we get to our index.js page here, we're gonna start by creating a class. As I said earlier, and this class is going to be person. Hopefully you've watched my other videos before this one on higher order functions. I've gone over higher order functions. I've also gone over objects and classes inside of JavaScript and spread operators, and all of those will be used in this video. If you haven't watched them, it would be a great idea to go ahead and watch them if you're not familiar with any of the content that you're seeing so far or in this video. So we have this class of person. We're going to make our constructor. We're going to give them a first name, last name, age, and occupation. So I actually did research on all of this information. This information is kind of inconsistent the way that Family Guy is written. Um, for example, um, Peter and Lois are like a year or two apart from each other in one episode. And then another episode, they state that they're like Peter's 10 years older than Lois, and then in other episodes, the age gap is shortened again. So I just chose ages that I felt was more appropriate or consistent, kind of, or just made more sense overall to the show. Like I feel like Peter's not 10 years older than um, Lois, for example. So, anyways, yeah. So we're starting off with making our person class. We're going to use this dot first name equals first name. This dot last name equals last name. This dot age equals age. And this dot occupation. What happened here? Age. And this dot occupation equals occupation. Okay, okay, cool. So give that a save. And I'm not gonna do all of these characters, but just in case, maybe you have watched these videos a couple weeks ago and kind of need a refresher. In order for me to make a new object based off of this person class, I need to create a variable, give it a name. So I have const Peter here. I'm gonna assign it new person. Once I've assigned it new person, I'm gonna fill in the parameters here. So we have Peter, Griffin. He's 43, the age we're going with, and he is a toy maker. I know his occupation has changed. I think he actually works at the beer factory or something now, Pantucket or whatever it's called. But we're just gonna go with this. And just to make sure everything is working, we're gonna console log person, and we're gonna console log Peter, and just see what we return here. And actually, yeah, we'll just cool little trick here. Instead of console logging for both of them, we're gonna do one console log and one console table. So if we refresh the page here and we look at developer tools, we see that we have this class of person, and we see that we don't return anything on line 13 for some reason. There we go. Just had to do another refresh, and there we go. So now we have this table that we can look at and see that Peter's first name. Last name is Griffin. Age is 43, and he's a toy maker. Okay, great. So everything seems to be working so far. We can see that it's an instance of a person that it's inherited the person class. And so instead of making you guys watch me type out all of these other characters, I'm just gonna go ahead and copy and paste them. I have them off to the side here to save time in this video. Um, so there we go. So we have everybody that lives in those houses that I mentioned previously. And now we have all this information, and now we want to do a little bit more with it, right? We want to use the high order functions to manipulate it and do different things with it. So the first thing we're going to do is we're going to put all of these characters into their own houses or their own family. And I'm going to start with the Griffin family. So we have the Griffin family. I'm going to create a variable called Griffin family. And inside of that, I'm going to put Peter. And notice that I'm using the spread operator here. So I could actually just put them inside of an array and just go Peter, Lois, Lois, Meg, whatever. And this would work. Like all of that information on those characters would be inside of this array. So far, we get an array with three objects with all of the information for Peter, Lois, and Meg. And the problem with that is if this information is altered inside of this array, or those objects themselves are altered, then it's altered in on both ends, and that's the reason that we're using the spread operator is because instead of pointing to a reference of these variables, we have a copy of it that we can manipulate on our own. Um, so yeah, let me just get through this. Who else do we have here? We have Chris and Stewie. Wow. Okay, cool. So if you were to console log the Griffin family here, just to make sure everything looks correct, do a refresh, and we have Peter, Lois, Meg, Chris, Stewie, and all of the information that comes with them. If you do a little drop down, we can see everything here. Um, yeah, so this looks good so far. Everybody has the information here. We use the spread operators to guarantee that we're making copies of these objects instead of just referencing the objects and being able to maybe accidentally alter information. So now that we have that going, we need to do the same thing for the Brown family. We also need to do the same for the Swansons, and Quagmire is kind of on his own, so maybe we don't need to do this for Quagmire, right? So yeah, let me do that real quick. I actually don't have these all made up to the side, so I'll have to try to type this out as quickly as possible. So who do we have in the Brown family? We have Cleveland. We have Donna. We have Roberta. Um, Cleveland Jr., and we have Rollo. Cool, and then also the Swanson family. So we have Joe, Bonnie, and Susie. Okay, great. So if we give this a refresh, save this, right? Okay. Oh, I'm not console logging anything. So, that's the exact reason we're not getting anything. I just want to ensure that everything is working as intended. So let's do console table for the fun of it. I'm new to using console table. I think it's really cool, so why not? Um, and then we have the Swanson family. Give that a save. Now we do a refresh, and there we go. We have all of the information here. We have the first names, the last names of everybody. We have age. Oh, and this table is really cool because I can sort data inside of the console. I didn't know I could do that. That's really, really cool. I'm learning this live on the fly right now. So, okay, cool. So we have this data here. We have it inside of our tables. We can see it all. Great. So the next thing that I want to do here is um, I want to use the spread operator one more time to put all people inside of it. Now I could do this a number of ways. I'm just gonna do const all people and um, have every character. So I'm just gonna actually copy and paste it like this. I had it off to the side. Thinking about it, I could probably just do a spread operator of the Griffin family, Brown family, Swanson family, and then throw Quagmire in there. I'm not gonna test that right now. I'm just gonna do this because I realized, I want to chop down the time that I'm spending on a video, so typing out a bunch of stuff sometimes is not the best thing time-wise. So now I want to map through this data here. I want to go through this all people array that we have here, and I want to get everybody's full name, right? So we have the full name for everybody's first name, last name, of course. And so there's one thing that we could do one or two things. Let's just get started writing on this actually. So I'm going to create a variable called full name. I'm going to set it equal to all people dot map person person dot full name. Oh, we don't have a variable called full name, right? So I could do person dot first name, um, and I could concatenate this and do like person dot last name. I could also use string interpolation and put everything in backticks and kind of do the dollar sign with the curly braces wrapping everything, and then I don't have to use this plus sign anymore. I can just have a space and then give that a save, and then I have the information I'm looking for. Or I could also just go to this object that I have here and create a new thing, this dot full name equals first name plus last name. So I don't think I went over this when I made the video for how to create classes inside of JavaScript, but you don't necessarily have to have everything in the constructor doesn't have to be inside of the class. So I just created a new variable called full name, and we can access this now. And like what all of these objects we have here also inherit this full name here. And so if I get rid of this and I just say person dot full name and give it a save and console log it, we should well, we're gonna console dot table because I think that's like so cool now. So we should return the first name of all of the characters on Spooner Street. So we refresh and there we go. We have all of the characters here and whatever index that they're at. And so we have first name, last name. We kind of want a space here. So it looks yeah, it looks kind of bad. So I'm just gonna use string interpolation here. Give that a save and refresh again. I don't think I put, yeah, I didn't put the last backtick. Okay, cool. So we have everybody's name. Everything looks good so far. Um, so so far we've created a class. We've created objects that inherit that class of person. We've created arrays that take multiple objects and using the spread operator, and we've now mapped through one of those arrays, and we've returned first names of all of the people from that large list of data that we have. And so that looks pretty good. Like this looks good. Yeah, so I think we've done pretty good so far, and we've used our first higher order function with map. So let's say we want to use some more higher order functions here, of course, right? Let's say we want to find all people with the last name Griffin here, right? So I'm gonna go ahead and get rid of that. And so I'm gonna make a new variable called Griffins just on its own. I think we've used Griffin family, so we're gonna use Griffins, and we're gonna go all people dot filter, and for every person that we have inside of this array, we're going to get person dot last name. And just in case, we're actually going to use the two lowercase method, and we're going to say equal to Griffin. And we can show why this matter. I'll show why this matters right after. If you do the console log Griffins real quick, do a refresh. We'll return this object, and we have everybody with the last name of Griffin, right? So everybody here, you can see that their last name is spelled with a capital G. But let's say if we go here um and we change Meg's last name to a lowercase g, right? So the way we have it coded now, when we refresh, she's still there, right? If I was to get rid of this two lowercase method here and just say a person that last name is equal Griffin, well, first off, I want to use a capital G here, equal to Griffin. What we're going to return here is 4. We're not going to return Meg here because her name is lowercase. And I say that to say there will be times where maybe you have a form, people are filling it out, it's going to a database, and people are putting names in a database, right? And you want to look for everybody with a specific last name, or you're looking for a user in general. And you say, okay, what's your name? Let me look you up in the system. And they give you the name, and so you go to type it in, you can't find it. And maybe they spelled their name with all lowercase letters or something. Well, it's not going to work the way that it's coded now. And so, best practice is to always kind of take data. In my opinion, best practice is take that data, make sure that it's all returned as uppercase letters or lowercase letters, and when that happens, it'll alleviate a lot of that frustration of things possibly being spelled the same but using different capitalization. And that can also work for things like names like McFarlane, or something that has multiple capital and lowercase letters throughout the name. O'Reilly or something. The way that one person might spell it might be a little different than yeah, than the way somebody else might spell it. They might say mix something and not put another capital letter. Whatever, I'm off on a tangent. But yeah, so that's why I wanted to do it like that. I just feel like it's best practice. And so we've gone through and we said we want everybody with the last name of Griffin, and we returned it. So it gets a little weirder when we look at the Brown family, right? So let's console log the Brown family real quick. I'm actually going to put this in the table because I think it is easier to read. And so when we refresh here, we look at last names for the Brown family, and we see that we have Brown, we have Tubbs Brown, we have Tubbs, we have Brown Jr. even. But how do we just say, yo, I just want to filter and look for people with the last name of Brown, they're in the Brown family, right? Maybe not necessarily. There's more than one last name inside of this family. So with that said, let's try to filter that. So we're gonna make a new variable called Browns. We're gonna do pretty much the same thing we did with the Griffins to set up filter, and for every person we want to do something, right? So here we want to do for every person inside of this this array, we want to filter it, and we want to look for person dot last name, and we're going to use another method you may or may not have heard of called includes. And if it includes Brown at all in the last name, we're going to return it, and then or returns person dot last name includes, and we're going to use uh, there we go. We're going to use tubs. So this is going to cover everybody if I've written it correctly. Dot last. Okay, cool. So this is going to look for everybody that has Brown or Tubbs in their last name. Notice all of them have Brown or Tubbs in some type of way. So we have different last names here. But it should all return. All of these should still return because we've used Brown or Tubbs anywhere in the last name. So we're gonna console log this back out, and let's see what we get here when we look for Browns. We do a refresh here, and they're here. They're all returned. We can see it's from line 46, which is where I did this console. And so on line 46, we've returned them all because we've looked for everybody that has a last name that includes Brown or includes Tubbs. The includes method, if you're still a little confused on how it works, it'll look through whatever array you tell it to look through, and it's gonna see if it includes something in general, and if it does, it's gonna return it. If it includes it at all. So I could put a letter. I could put the letter B. It would have still brought all of them because their last name in both last names Brown and Tubbs have B's inside of them. So yeah, we're in a good spot here. We've used filter for a couple different things. We've used map. You can see that we've also just thrown in other methods here like two lowercase and includes. We've used the OR operator with the double pipes. So let's see, what else could we do here to get some more information? We could even filter to get specific occupations here. So let's say we want to find everybody that's a student, right? Well, actually, yeah, let's do it. Const students equals all people dot filter once again. We're gonna stick with this person variable that we've been using and say for every person, if person dot occupation to lowercase equals student, and here's where we're gonna map multiple higher order functions together here, right? So we're going to use map, and for every person, we're gonna return their full name, person dot full name. Okay, great. So let's look at this again. We're creating a variable called students. We're looking through that all people array that we have. We're gonna filter it for people that have a occupation of student, and then once we return those people, we're gonna map over what's returned there. And for every person inside of that array, we're going to get their full name, first and last name. So here we're gonna console dot table students, give that a save, refresh here, and we have May Griffin, Chris Griffin, Roberta Tubbs, Cleveland Brown Jr., and Rollo Tubbs are all students. So you might notice that I put Rollo and not Stewie and Susie. Who knows? They don't really go to school in most of the episodes. Rollo's in pre-K or something. The rest of them are just kind of chilling at home with their parents. So, yeah, this is pretty cool. We can see how we can even chain higher order methods together. Here we use the filter method. inside of that, we went into our object and we're using dot notation and we're, using the lowercase method, two lowercase method, and then, we're mapping over everything that's returned after that and we're getting more information. So we're just going deeper and deeper into it. And so we have this right now. And let's say we just want to, we have all students, but let's say we want to get high school students, right? We don't want to get every single student. We just want to get high school students. So we'll come back here. Um, we're going to comment that one out. And we're going to make a variable called high school students. And we're going to kind of do this same thing. So I'm actually just going to copy this part, right? So we're looking for students. Cool. So far we're looking for everybody that's a student, right? We're filtering this list, looking for everybody that's a student. Well, now we're gonna use the and operator here using double ampersands, and if person dot age is greater than or equal to 14, we're gonna assume if you're 14 or older that you're in high school. Um, we're going to map over which return there, and for every person inside of that returned array, we're going to find person dot full name, and we're just going to return their full name. So with that, we do a refresh here. We're going to refresh again. We're going to realize that I didn't console log anything. So I'm going to do a console dot table of high school students. We're going to give that a save. We're going to refresh here. And boom, we have Chris Griffin and Rollo Tubbs. I messed up somewhere. So, Chris Griffin and Rollo Tubbs, I probably did this. I put less than or equal to 14. So if we do greater than or equal to 14, like we should have, we now get May Griffin, Chris Griffin, Roberta Tubbs, and Cleveland Brown Jr. Okay, cool. So easy fix. And now we're getting everybody that's over the age of 14, and we're returning them. I forgot Meg's last name was like messed up, but whatever. It kind of bothers me when I log it, so let me fix that. Okay, cool. So we have that information here. Um, And so far we've chained multiple higher order functions together. We use filter, we use map, we didn't use for each. I'm not going to use for each in this video. There's nothing wrong with for each. For each is a great higher order function. It definitely has its place. Um, However, for each is kind of generic in a way that if there's a better higher order function to use, you should use it. So if you can use for each, the for each method or something, but you can also use map, you should probably just use map. So anytime the for each method can be used, but you can think of another function that can be used instead, you should probably just use that other higher order function. Just a tip. So there was times where I was like, I can use for each, and then I just decided why. Um, the last thing we haven't touched on is reduce. We haven't used the reduce method. So we're going to do that really quickly by just getting the average age of everybody, all these families. We're just going to get an average age of them. So I'm going to console, I'm sorry, I'm going to comment these out. And I'm going to make a variable called average age. We're going to go into the all people array. We're going to map over that. We're going to take each person and we're going to return person.age, and then we're going to reduce it. So we're going to chain the reduce method onto that to whatever is returned here. So when we map over this, we're going to get all the people's ages. We're going to reduce it. We're going to take and I'm just going to use P and N for previous and X. So if you looked at my videos for reduce, you know that you have to give it a accumulator and a accumulator, and wow, I'm kind of drawing blank on the correct verbiage here, but pretty much you want to have one number that they're gonna have, add another number, and then it just does a whole thing. I'm explaining this horribly right now because I can't think of the words and it's throwing me off, but just watch the video if you haven't. If you have, then you already know. If you know, you know. If you don't, watch my video on reduce. So we're gonna take p plus n. We're also going to start it off with zero. Um, so we're gonna make sure that it starts with zero. There's just nothing to begin with, and then we're going to divide that by all people dot length to get that average age here, and then we're gonna counter it. All right. So just to recap really quickly, going to look at the all people array. We're gonna map over that array, and for every person, we're gonna return person that age, and then we're gonna reduce that, and we're gonna start off with zero, and we're gonna reduce everybody's age down to one number. Once we get that one number, we're gonna divide that by all people that length, so we can get the average. So that's how that math works out. We're gonna do a refresh here, and we get 27.428 and a bunch of other numbers. So pretty much the average age of people residing in these residences and on Spooner Street is 27 years old. Right? So that's pretty much it for this video. Hopefully you got a lot of information here. I just wanted to really show how to use the spread operator and use higher order functions with a bigger data set than we have had in my previous videos. Also wanted to show using the spread operator in these instances, chaining higher order functions together, chaining different functions together in general, and I just wanted to show what you could do with higher order functions and how powerful they were. So, um, if you're not subscribed to the channel, I have to get to this part. I wouldn't be doing my job right if I didn't. But if you're not subscribed to the channel, please go ahead and subscribe. I have a lot of new content coming. I haven't been putting out content as often as I was a few weeks ago. Just been really busy with life. However, videos are still coming. They're going to ramp up as I get time to record and just build up how many recordings that I have. So definitely subscribe. If you want to get alerted whenever new videos do come out, there's a bell icon somewhere on the page that you can click to get alerted whenever I come up with a new video. Um, in addition to that, if you have any friends that are new to programming and getting into programming, I do have my series on introducing web development, starting from HTML. The next video in that series will be introducing CSS, and at some point we'll be bringing in JavaScript. So, and if this video helped you at all, if it helped you understand higher order functions more, if you learned how to chain them together, if it just helped you see exactly how powerful they are, go ahead and drop a like on the video. I greatly appreciate it. It helps me get into the eyes of more people if you do so. And yeah, that's it. Thanks for watching, and I'll catch you in the next video.